I would like to thank first IIT Madras, INEAS, especially Dr. Sweta and Dr. Gunte for the invite, and I also would like to thank all of you for participating in this particular workshop. So I'll be talking about the recent developments that we made in new particle formation studies in India over last, I would say, decade. I started working on new particle formation when I moved to India back in 2016, and since then I have been actively working on improving our understanding of aerosol microphysical behavior in India. So, just to briefly introduce, to set up the stage for my talk. Aerosols, everybody knows, they are ubiquitous in the atmosphere, and there is a tendency to relate many things around us to aerosols, whether it's the weather, climate, air quality, health impacts, even to some extent vegetation as well. Mainly for a couple of reasons. One is if you look at the difference between the smallest and largest particle, it is about 4 orders of magnitude. And if there are no aerosols, there are no cloud, there is no rainfall, there is no water. It's just because we don't have homogeneous nucleation of water vapor, for which we require really high supersaturation, which is about like 200%, that we don't have. So aerosols act as foreign particle upon which water vapor diffuses and the cloud forms. So there are, of course, as Dr. Panditra mentioned about direct effect, indirect effect, and so on. And as he rightly pointed out, it's not just the chemical composition, it's not just the size, but both actually size and the chemical composition that decides the property of the aerosol that we have. When it comes to the sources or types, there are mainly two: primary, secondary. Primary one which are directly emitted to the atmosphere, and the secondary one which are physically or chemically transformed in the atmosphere. And my interest lies in the secondary aerosol formation, where you can again have two possibilities, where the vapor can diffuse onto the pre-existing particles by condensation, or you could have also aerosol nucleation, where gas to particle conversion takes place, and the precursors, aerosol precursors, forms new particles in the atmosphere. So what we call as aerosol nucleation, or aerosol dynamical processes, or aerosol microphysics, and most widely I'll be referring to new particle formation. So what is nucleation? Nucleation is nothing but the aggregation of gaseous molecules. So in simple words, you have same or different molecules aggregating. That's what we refer to as aerosol nucleation. But the aerosol nucleation process itself reduces the enthalpy, that is total content of the system, and the entropy of the thermodynamic system. And therefore there exists a barrier. The black line, what you see, is the particle mode diameter. And you can clearly see that particle as small as, let's say, 1 nanometer or 3 nanometer, reaching up to 100 nanometer within a day or within 8 hours. Okay, so this is how we detect. But for characterization, you need all these instruments, and if you just sum up the amount of money that we'll be needing is close to 20 crore. So you need to have a lab with all these equipments in order to characterize the NPF, understanding what is the chemistry that drives NPF, or what is the atmospheric condition that drives NPF, and so on. So what we call them as a banana plots, because they look like a banana. So idealization of banana is basically representing the real new particle formation taking place in the atmosphere. So for characterization, first we look at what is the frequency, how frequently new particle formation occurs in the atmosphere, what is the strength of new particle formation, so by calculating its formation rate or growth rates. Then we also look at whether there is atmospheric or synoptic condition that can influence the occurrence of new particle formation. It may suppress, it may inhibit, and so on. And such characterization of NPF has been widely reported from across the globe, including India. But there is very little knowledge, or I would say probably none, in Indian context. We don't know yet what is the chemistry that drives new particle formation, except one study where we used AMS TOF to look at the chemical composition of submicron aerosols during new particle formation events. Because AMS usually start around 40 nanometer, and its sensitivity is I would say significant sensitivity start around 60 nanometer. So all new particle formation processes occur below 40 nanometer or even 30 nanometer. So AMS is not best suited instrument to study the new particle formation, but yeah, something is better than nothing. That's what we say. So we did use, and just to see if we can get something out of it. Yeah. So when I came back, so what was my motivation? I say known unknowns. Known because we know, either in global context or even in Indian context, and still there are unknowns because probably we don't have that capacity building, or we don't have that infrastructure to address our hypothesis, whatever we have. So NPF is the largest source of aerosol numbers that occurs throughout the terrestrial troposphere. It contributes significantly to the CCN concentration, about 0.5 to 11, by factor of 0.5 to 11, and NPF is expected to be less favored in polluted environments because of high pre-existing aerosols, because most of these precursors or particles are scavenged by the pre-existing particles, and it is more favored in clean environment where you have very low concentration of aerosols and so on. But developing countries like India and China, we calculated the sulfuric acid proximity. So you can see there is a very good association among all these three parameters, which basically says that sulfuric acid is the driving for aerosol nucleation in the atmosphere. Now, while we observe that sulfuric acid is the driving species contributing to new particle formation, you can see there are two types of events, type 1 and type 2. This is again from the Hyderabad. So the first one is where you have a particle burst, and then subsequently those particles are growing in size over the time, reaching up to 100 nanometer. Whereas in the type 2, what you see that you have even stronger burst of subcranial nanoparticles, but you don't detect anything in SMPS. So it's not just sulfuric acid which can explain the growth of these particles. Okay, there has to be something else. So maybe ammonia, amines, organics. So we observed these kind of events about half of the days when we saw the particle burst. Whereas in a very recent study, which is led by Aishwarya, and what we found that sulfuric acid can explain not only the particle formation but also the growth. And these measurements were conducted during the COVID-19 lockdown. We observed about 2 or 3 new particle formation events over the period of I think 2 months. And all those events were under the influence of sulfur plume from power plants. And what we found that about more than 40% of the total aerosol mass was explained by the sulfate, which is very rare in a global context as well. So this is also one of the very good results. Then our another study again during COVID-19 lockdown, where we found that because of COVID-19 lockdown, most of transmission activity were shut down, and the aerosol concentration or the precursor concentration were low during the lockdown. You can clearly see the color contrast between these two figures, the SMPS data during 2019 business as usual and 2020 lockdown. You have much lower aerosol number concentration in the atmosphere. So what is being observed at, let's say, in Finland or in America, where they see that if you have a lower aerosol concentration in the atmosphere, which should favor or which should promote the new particle formation, but that is not what we are observing here. Okay, so you can see the new particle formation frequency reduced by about 3-fold in the picture shown in the bar graph. And we tried to explain why the electric frequency was reduced during COVID-19 lockdown, and what we could find that when we look at the formation rate and growth rates of subterranean particles, what we found they are similar between the 2019 business as usual and 2020. So it's not their formation or growth rates, but maybe their photochemistry. We found a lower ozone concentration during the lockdown. We also have a lower temperature during the lockdown. Symposium on secondary aerosol formation and growth earlier this year, Nano 2023. So what is the way forward for India? Yeah, I always say develop adequate capacity for key aerosol processes level studies and encourage synergy between observations and modelers. Because as an observation person, I can detect something what is happening in the atmosphere, but I need modeler to explain. why it is happening, and what would be the mechanism that leads to the aerosol process. National and international collaborations for capacity building for a consolidated determination of aerosol effects on air quality, climate over India. So it could be multi-slide, multi-platform, multi-institutional, and it should be continuous and long-term, not just campaign mode. So we need to have a really, at least a 1 year measurement at a particular site to know what is exactly happening at that particular site. Okay. So basically, more and more observation at more and more places. So that's thing I would say. So this is the review paper I was talking about, atmospheric new particle formation. So I'll take another only 2 or 3 minutes for that. Artifice Science in association with Agent Control, they have developed animation based on our review paper. So I just would like to play that.
Our atmosphere, a complex mixture of gases, contains a vast and intricate realm of minuscule particles called aerosols. Aerosols can range in size from a few nanometers to several micrometers. And this variability occurs due to a multitude of factors. One of the factors that impacts the size of aerosols is specific geographical location in which they exist. The size also depends on the prevailing weather conditions in different geographical locations. The source of air pollution is another crucial determinant of aerosol size variability. The aerosols emitted from these sources are directly released into the atmosphere and are known as primary aerosols. Anthropogenic emissions of precursor gases and aerosols can undergo physical or chemical transformation to form secondary aerosols. On the other hand, secondary aerosols can also be generated from scratch when gaseous precursors undergo nucleation to form new particles of nanometer sizes. When these particles grow and reach a critical size, they become active cloud condensation nuclei, which plays a crucial role in cloud formation and precipitation. The process is known as new particle formation, or NPF. NPF events. SMPS operates based on the principle of the mobility of a charged particle in an electric field. It allows scientists to measure and characterize aerosol particles based on their size. SMPS technique is widely employed in atmospheric research and environmental monitoring to detect even ultrafine particles. The graph plotted using data from scanning mobility particle sizer exhibits a distinct curved shape, often referred to as the banana plot. The banana plot is a characteristic feature in the graph, showcasing the evolution of particle sizes over time during NPF events. Observations of the formation and growth of new atmospheric aerosol particles have been documented mostly in Europe, China, and the US. However, such observations are scarce in India. A review of total of 25 published studies in India on NPF provided valuable insights into various aspects of NPF events, including the factors that influence and regulate NPF. These studies were conducted in different atmospheric environments such as urban, semi-urban, urban coastal, semi-rural, mountain remote, mountain background, mountain semi-rural, and cruise. For example, studies show that new particle formation took place during periods of heightened solar radiation and less in the absence of sunlight when the intensity of solar energy is its least. Another study showed NPF occurrence to be higher in urban areas compared to rural and mountain background sites. In a significant breakthrough, a study conducted in India established likelihood of newly formed particles surviving and growing to sizes that make them cloud condensation nuclei, which is typically above 50 to 100 nanometers. In India, most studies have focused on size distribution of aerosols, but underlying chemistry is still unknown. Also, the precise contribution of newly formed particles to cloud condensation nuclei production and their potential for cloud formation remains uncertain. Further investigation is essential to unravel the intricacies of this process. Another aspect of new particle formation that requires further assessment is the relative contribution of volatile organic compounds to new particle formation. And most importantly, the role of NPF in haze formation requires further research. Foster collaboration and commitment among researchers, institutions, and stakeholders. As we venture into this uncharted territory, unified efforts will lead to groundbreaking discoveries, illuminating new paths in atmospheric science. This shall enable us clouds and the Earth's climate system, which is still to be fully comprehended.